Hey, you 13s, how's it going? I am so sorry. I thought I was giving a year 10 lesson and I completely didn't check my timetable. Completely missed that. Hey, you 13. And so I have fixed it. We're going to be doing, obviously, Unit 2 Kinetics, Lesson 2, Calculate K and its units. Okay, I'm just going to run the register real quick. I know that most of you guys are already here, which is great. Sorry guys, I'm not feeling great at the minute, so I'm just I'm gonna have to take it a little bit easier than I normally do. Feeling a bit rough at the minute. Don't know why. Got Dat. Have I got Rhea? Certainly got Dat and Dana and Jasmine. Have I seen Rhea? Where's Rhea? No Rhea yet. Got Jasmine. Kayun. Got Ivan. Got Ben. There's Rhea. There's Kayun. There's Jasmine. There's Mika. Isn't? There's Rhea. There's Kayun. There's Ben. Tenzi in the house. Don't know. Emma. I've got Ivan. I've got Nikita. I've got Nikita. Are you actually going to watch the webinar this time instead of wandering off? Just missing Tenzi. Ah, there's Tenzi. I love that. Rhea's like, I'm here. What are you talking about? Cool. Okay. Got a full house. Guys, we're done. Look at that. Okay, so I set you guys a homework. Let's see if we can. I'm going to share my screen with you guys, and then we can crack on. So share that. There we go. Hide that one. Right, so I set you guys a homework of working out the orders. I left it on the classroom. Let's see if I can track down my worksheet. This is where I'm gonna have problems all the way through with this, only because I was set up ready for my year 10 lesson and then suddenly realized that I'm in the wrong one. Lol. 12E. There you go. There was your kinetics homework. One person has turned it in. Yeah, I do realize, by the way, that the part 2 down here, the question 2, I'd finished doing the rate equations with you guys, but I hadn't talked to you about the constant and its units. So we're going to do that today. I'm hoping that you guys have had a go at doing it. It's basic mathematics, which makes everything a whole lot easier, which is good. It's very straightforward maths. So if I go A2 Kinetics homework 1, I'm going to set you guys another homework today. So on the chat, get rid of my register. So on the chat, there we go. We have to turn it in. No, Donna, don't care about turning it in. I love the fact that someone did. In reality, I don't. Has everyone finished it? Did everyone have a go? Ben didn't do it, did you, Ben? Guys, I'm going to be setting you a homework pretty much every lesson while we do this, and they need to be done for the next lesson so that I can go through it. I've downloaded that now, so what I can now do is go, right, title is A2 Kinetics, learning objectives. I put them on the classroom. On the classroom, lol. I put them onto YouTube, so they're there. So we've got learning objectives. Be able to calculate K. Calculate. I'm sorry, I'm going slow today, guys. I will speed up momentarily. Yeah, and then no factors affecting K. And then be able to determine units. As I said, I'm hoping that you guys will have already done all of this yourself. Be nice if you had. Let's go for 18. There we go. Okay, so I'll get rid of my keyboard. There we go. Keyboard's going to break soon. We're pulling it off and on every day, 5 times a day. It's not good. Okay. So I'm going to now insert, put my mouse there, and then go insert printout. Should be able to find your homework and we can run through it. There we go. Cool. So what you had to do is you had to figure out the order with respect to each of the reagents in these questions. Just going to check. So that's it's nice. We have to turn it. Dat, yes, Ben. I did. Good, Ben. Glad to hear it. Dana, yep. Nikita, yep. Ben, Ivan saw it. Ivan's like, I did. Ah, brilliant. So I've had like 5 people say they've done it. Donna, did you manage to get it done? Emma, did you manage to get it done? Nikita, did you manage to get it done? I'm gonna create a sheet as well for us to start collecting our homework values. So they need to be finished so that you guys can. Otherwise, I'm gonna go through them, and you guys won't be able to know whether or not. I mean, you'll see me going through them. You then technically wouldn't really need to. Ben, yeah, I sent it to you on WhatsApp. I was the one that turned it in. Good job, Ivan. Well done. Emma, thank you. So I'm going to go to Google Sheets. I'm just going to create a document that we can collect our data in. I've been collecting my year 10 data on all this kind of thing. This is year 13, because of course you guys are year 13 now, which is amazing. Go on, let me name my sheet, you mean thing. Oh, it says working, that's why. Hide. There we go. Keyboard. My laptop's having trouble. Don't know why. Like, we're in lots of trouble. Let's do. Oh, I prefer. Should probably collect them in year 13. A2. Homeworks. Cool. And then I'll share the link with you guys. So I'll sort out all the names and everything. I'll do it later. I'll crack on with this, and then I'll just do the Kinetics homework is going to be. There we go. Kinetics 1. I don't know what the score is going to be out of yet. We'll figure that out in a minute. I'll leave that there for a minute. Okay, so let's go through it. So did everyone have a go at actually working out K as well? Because if you did, it means that I can kind of go through the answers, and we can use that answer as a basis for being able to learn how to do working out a value for K. So, okay, so let's do number 1 first. So from A, draw. Okay, there we go. I'm going to make that a bit thinner, actually. Okay, so stayed the same. Yeah, stay same, kept same, keep same, KS, whatever you want. Times by 2, times by 4. A is second order. Yeah. Next. Stayed the same. Stay same. Times by 2. Did absolutely nothing. 0 order for B. We're done. Right, we can now create the rate equation. So 1 mark for second and 0. Yeah, 1 mark for those guys. I'll do that in red. 1 mark for the 2 values. Rate equation. Rate equals K, A to the power of 2, and we're done. Right, now this is where my lesson kind of goes from being a homework run through to being an opportunity just to teach from this. So in order to calculate a value of K, in fact, I've got to be careful here. No, okay. Let's do the rest. Let's do the rest and do the rate equations, and then I'll do some notes on calculating K. Okay, so stayed the same. Times by 4. Times by 4. So D is first. Done. Next. Right, gonna have to step this one. Doesn't matter because D is never kept the same. So I'm gonna have to step it. Choose 2, doesn't matter. I'll choose there and there. Times by 8. Ooh, now we know that D is first. This one I need my calculator. We know that D is first order. So in order, times by 8 according to D. So 5 times 8 gives me 40. Any change, that's gone up by a factor of 2. What did I do to E? And the answer is times by 2. So E is also first order. Nice. Makes things easy, doesn't it? First and first. 1 mark for the 2 numbers. Equation. Rate equals K. D e to the power of 1, e to the power of 1. That's it. The number in the equation makes no difference. We know this. Next. The numbers are going to get more and more messy, aren't they, as we go through. In the second one, it's even harder. So kept the same. What do I do to that? Oh, divide by 2. What do I do there? 12 divided by 3 is going to be 4, I assume. Divide by 4. So that means that H plus is second order. That's clever. It's not even in the equation, you notice, which means it's a catalyst. Yeah. But it still has an order. It still will appear in the rate equation. Right, next one. H is never kept the same, so it doesn't matter what we choose. I'll choose these two this time. So this one's been divided by 2. So whatever that's done here. Oh, hang on. Sorry, can't do those two. I need to change J. I'm an idiot. So I'm going to do these. I'm going to do these two. Divide by 2 there. What did H do? H has been multiplied by 4. If you're wondering how I did it, I just did the bigger divided by the smaller. That's all. Yeah. So that's been multiplied by 4. Whatever that's going to have done, so that's going to be times by 4 as a, oh, no. Times by 4 squared. So 3 times 4 squared, because it was a times 4 second order. It would have gone to 48. Whatever that's done, which is a divide by 2, is a consequence of J. And J has been divided by 2, so J's first. Rate equation. Rate equals K, J to the power of 1, H plus to the power of 2. And we're done. I like it. Next. Steadily going to get tricky. After a while, you kind of get used to doing this. As I said, when they flip the table around, it's a bit of a nightmare. Oh, 3 people this time. So a bit more stepping going to be needed. It's going to be a bit more messy. So, okay, stayed the same. Keep the same. Oh, can't do those two because those two both change. Don't know yet. Can't do that. I need 2 people to stay the same. There and there. Right, so what did I do here? This was a divide by 2. What did this do? Divide by 2. Q's first order. I like it. Now we've figured out Q, so Q doesn't have to stay the same. Yeah, we need to find now P or H plus. What do I fancy? I'll go for, let's go for the first 2. Let's go for H plus. So we know that this one's now first order. That's been times by 4. Yeah, we know that P is kept the same. Yeah, so with Q being first order, we know that that would have gone up by a times 4 as a result of Q. So 8 times by 4 gives me 32. Whatever it now goes to is as a result of H plus. What did we do to H plus? H plus was multiplied by 2, and this was also multiplied by 2. H plus is first order. I like it. Rub them off. I do it in pencil in my exam and then just pencil them back in and then just rub it off. Right, now it doesn't matter what we do as long as we change P. Yeah, everybody's changing now. So we've got, let's do it step by step. H has been divided by 4. So as a result of H plus, it would have gone divide by 4. So 32 divided by 4 gives me 8. That's as a result of H plus. Next, that then has also been multiplied by 4. Oh, interesting. So that's been multiplied by 4. So I'm now going to multiply that by 4 because it's first order. Yeah, so that takes me back to 32. Right, and it's gone from 32 to 32. Nothing's happened. So P is 0 order. So rate equation. Rate equals P vanishes. K shows I'm not feeling very well. K multiplied by Q to the power of 1 and H plus to the power of 1. I'm done. Next. Okay, again, numbers just getting a little bit more tricky. Not really. Still no 10 to the minuses anywhere. In fact, this worksheet doesn't have any of the 10 to the minuses, which is actually makes things a whole lot easier. Okay, let's go to the next one. Right, find someone who stays the same. Okay, T stayed the same here. Here to here, T stayed the same. Right. Oh, sorry. T stayed the same. What did I do to S? I doubled it times by 2. What did I do to that? No change. So S is 0 order. Rub it back off. Next, now that we know that S is 0 order, doesn't matter what we choose, we'll do the first one. So S was divided by 5, but it'll have no impact, which is great. So according to S, it would stay as 300 because it was 0 order. Yeah, but then it went from 300 to 450. Oh, that's interesting. Multiply by 1.5. If you ever want to know, just take the bigger divided by the smaller and it'll tell you the multiplier. Times by 1.5. What did I do here? Times by 1.5. I like it. 2 times 1.5, and I get, of course, 3. So we've got T as first order. Cool. So rate equation. Rate equals K. Really not feeling very well. K T power of 1. I like it. Nice and easy. Next. I'm going to show you a real life scenario in a minute, folks. In fact, I'm going to give you it as a question on the classroom. So, okay, keep the same. Okay, that's, interesting multiplier. 0.05 divided by 0.02 gives me a multiplier of 2.5. Multiplied by 2.5. Yeah. Okay, what's that gone up by? Okay, so that's divide the bigger by the smaller. 0.1 divided by 0.016. 6.25 that's gone up by. Ooh, what's 2.5 squared? 6.25. W is second order. I like it. Next. Right, now that we've sorted out what W is, it doesn't matter what we do because we know that it's second order. So we're going to go for these. Let's go for this one. So that's going to be W is times by 2 squared. So whatever this does here. So I'm going to do 0.016 multiplied by 2 squared. That's going to go to 0.064. Right, now I need to go from there to there. What have I done? Big change. Bigger divided by the smaller. 0.4 divided by answer. Multiplied by 6.25. Interesting. What did that do? We've multiplied that by 3. Oh. So have I made a mistake? Have I made... yeah, I have. You see, isn't that fascinating? It came out in the wash. I made a simple arithmetic error. Yeah, this isn't a times by 2. Look at the numbers. It was actually a times by 5. Yeah, but it came out in the wash. The numbers didn't match up. So that was actually that is actually a times 5 squared. There you go. So it's nice that it came out. Shouldn't it be divided by 2? No, I made an error, Nikita. I made an error here. Yeah, I'm just going from 17 to 19. W second order. I did 0.1 divided by 0.02, and that's a 5 to the power 2 squared. So that one will have gone up by times 5 squared. 0.016 multiplied by 5 squared gives me 0.4. Ah, there we go. 0 change. That went up by times 3, but it had no impact. X is 0 order. So the rate equals K W to the power 2. Done. Nice. But do you see how I am as fallible as the next person. But if you have good routines and good patterns and know what to expect, then it actually often means that quite often if you're doing things in a nice routine, it'll come out in the wash. Numbers won't match up and it's like, oh, hang on a sec. Where did I go wrong? And it'd be usually quite easy to figure out where it was, just like mine was. I just ran the process again. Got my multiplier factor wrong. That's all. Next. Did I write the rate equation? I did. Right, next. These ones kept the same. This one's a times by 3. What's happened to the rate? Oh, it's gone up by a lot. Divide the bigger by the smaller. Divided by 0.15. That's gone up by a factor of 9. Oh, and that's 3 squared. M is second order. Next, just rub it off. Makes sense. Doesn't now matter what I choose as long as I change n. I'll do these two. Yeah, so that one, oh, that's an interesting multiplier. Divide the bigger by the smaller. 0.3 gives me a multiplying factor of 1.33. Right, so we know that that's going to be 1.33 squared on its impact on the rate. So I now do 1.35 multiplied by 1.33 squared, and I get 2.388, which is interesting because it's pretty much the same as that. So that's going to be a 0 change. So n's going to be 0 order. Yeah, winner. Rate equals km to the power of 2, and I'm done. Right. So in terms of scoring wise, yeah, we have 1 mark for the orders, 1 mark for the 2 orders, or the 3 orders, and 1 mark for the rate equation so far. Okay. Next step, question 2. For each of the rate equations you deduced in question 1, calculate the rate constant. Okay, so guys, title please. Calculating rate constant. Rate constant and units. Okay. So, nice and straightforward. First thing that we know we're going to have to do, folks, is reorganize. Yeah, so we know that if you have a rate equation, rate equals k, yeah, we're going to have to reorganize this. So step 1, yeah, calculating rate constants, step 1. Step 1, reorganize, make k the subject of the formula. Make k subject. Oh, pen's having a... I do every now and again, you guys know that I have this minor issue with my tablet every now and again. Oh, subject. It does this every now and again. I don't really know why. I don't know whether or not it's a pen issue, whether or not it be a tablet issue or what. Subject of, oh, let's close that down. My laptop's having a Barney. So typical. Let's try that again. See if this fixes it. Fingers crossed. There we go. It's not looking good. Subject of, there we go, of the formula. Let's do the first one. Use the first one as our example to be able to do this. So rate equals k, a to the power 2. So step 1, rate equals k, a to the power 2. Well, that's not hard, is it? Rate divided by a to the power of 2 will give me k. This is not complicated, guys. This is simple maths. Yeah? Right. Now what do you do? Step 2. Step 2. Select a complete run/string of data. Yeah? You need a complete set of data. So we go to my table for A, and I go, I need a full string of data. I can use any one of these, folks. Any one I like. Yeah, it don't matter. Because all the data's complete. If there was a gap, I couldn't use it. You must have a complete string of data. All we now need to do is input my data. We know that B is 0 order, so B doesn't even matter. Don't even bother. 3 and 10 is all I need. Yeah, 3 and 10. Go back down here. So I'm going to insert my complete data. So the rate was 10. So my equation is rate over a to the power of 2 equals k. Input my data from the string. The rate was 10. A was 3 squared equals k. And then just run it through my calculator. This is really easy. Let's just check that I got those numbers right. 10 and 3. Yeah. Winner. Right. 10 divided by 3 squared gives me a k value. So I can go, therefore, k equals 1.11. Right, now we need to talk about units. Step 3. Yeah, step 3, units. Now, what I actually do this differently from other teachers, and it does vary depending on what you read. I prefer creating the unit equation. So, step 3. Deduce units. Deduce units of k. Now, just so you know, k always has units, but they vary. Yeah, but they always have units. The reason why is because what you need to do is you need to convert this equation here into a units equation. So the top number was rate. Top number was rate. So what we need to do is, what are the units for the rates? Now, the great thing is rates units is told you in the table. The rate unit is moles per dm cubed per second. The reason why k always has units is because you can never get rid of the s to the minus 1, just so you know. So this is the units for rate. Rate units. Next, right, that is over a squared. Well, that's the same as a times a. So that's 2 sets of units for a. A is appearing twice. Now, a was a moles per dm cubed. It was a concentration, but there are 2 of them. The reason why there are 2, yeah, is because a is to the power of 2. Yeah, why is it? The answer is because it's to the power. If it was, dumb question. Should you always use the data from the first initial experiment, or it doesn't matter here? In fact, one of the things that you guys can always do is you can always check this, because the rate constant is constant, which means it doesn't matter what data string you pull, you'll always end up with the same number. It's one of those white flags of, I got it right. Yeah. So there are 2 A's, therefore 2 moles per dm cubed. Right. Now what you do is you now cancel what can cancel. So what can cancel here? I'm going to do it in blue. What can cancel? That cancels with that one. And that is it. They cancel because the one's on the top, one's on the bottom. Right. So the units of k, you could then argue that you could do s to the minus 1 over moles per dm cubed. But we all know that you're not allowed to leave units like this anymore. Yeah? No, great question, Ria. You can't leave the units like that. Yeah? We learned in GCSE, moles per dm cubed. Yeah? But you're not allowed to do this anymore. That's an incomplete equation. That's actually moles over dm cubed. And what you have to do is you've got to bring the bottom denominator up. It's called it's called reciprocals in maths. I need to bring this entire thing up to the top. I need to flip their powers. Yeah? So I'm going to get mole to the minus 1, dm to the plus 3, s to the minus 1, because it's still on top. And we're done. There are my units for the rate constant in step 1. There they are. I'm sure there's going to be a handful of you guys who have already done this, which is great. Yeah, what I'd now like you to do is, if you did not do the rate equation and work out a value for k and its units, you can pause the video now and have a go at them. And then you can run the video back at high speed to check to see if you're correct. Let's do the rest, folks. Right. So we've now done all of our processes here, and we know that k now has a value of 1.11, was it? 1.11, yeah. And the units are, so 1.11 moles to the minus 1, dm to the plus 3, s to the minus 1. There you go. Right, let's do it for question 2, folks. Let's do it for question 2. Right, step 1, create your rate equation and select your, step 1, reorganize. So rate divided by d to the power of 1, got to be outside the brackets, d to the power of 1, e to the power of 1 equals k. Right, input your data string. I'm going to choose the middle one this time. There we go, full data. Full string with everything I need. What if you use e, then wouldn't the units for k change? If you use e, what? E? What? I don't understand the question, Donna. What if you use e? Where's e? Anyway, I'll continue doing this while Donna explains her crazy question on the chat. Input my data. Well, rate equals 20. There's the rate value. So 20 divided by, right, 0.4, 0.1. 0.4 to the power of 1, 0.1 to the power of 1. Gives me k. Right, well, the great thing is that just question E. Well, yeah, if you do a different question, you get different units. Yes, k's units depends on the rate equation. Thank you, Dat. I don't think she's quite understanding this. Donna, every rate equation gives you a different set of units for the k. That's kind of why I'm teaching it to you, Donna. So 20 on my calculator, 20 divided by brackets, 0.4 times 0.1. I get a rate constant of 500. And what are my units? Right, my units are going to be moles per dm cubed per second over, there's 2 of them, folks, and all to the power of 1. So that means there are just 2. Yeah, and the great thing is it means that maybe this is where Donna's question's coming from. Yeah, that cancels with that. It gives us exactly the same units as we got before. Give the reciprocal, mole to the minus 1, dm to the 3, s to the minus 1. Done. Right, so tick it for your value. Tick your units, guys. Yep. Next. Right, rate equations down here. Oh, units are going to be different. Oh, okay. Good. Fab. First step, reorganize. Rate divided by j to the power of 1 and h plus to the power of 2 gives k. Right, choose a string, a set of data. Choose the last one this time. Why not? You know, can, do whatever I like. Whichever's got, as long as it's a full data string, we're good. So rate is 24 over j at 0.1 to the power of 1 and h plus of 1 to the power of 2 gives me k. Let's run it through my calculator. 24 divided by brackets 0.1 multiplied by 1 squared. So I get a value of k of 240. Units, now my units are different because I need to convert this into a units. Moles per dm cubed per second over 3 of them. The overall order tells you the number that are going on the bottom. So moles per dm cubed, moles per dm cubed, moles per dm cubed. Right, cancel what cancels. Add those 2 together before giving the reciprocal. So that becomes s to the minus 1 over mole to the power of 2, dm to the minus 6. Flip the reciprocal. Final units are moles to the minus 2, dm to the plus 6, s to the minus 1. Now, if anybody's unsure, one of the great things I love about this is, guys, if you're ever wondering if you're correct, I always love this, knowing if you get something right. Well, you can just run this backwards. Yeah, if I just look at that data set, if I input K into the equation with this and this, it's going to give me my answer of 24. So I go 240, yeah, multiplied by brackets, 0.1 to the power of 1, and I'm even writing it exactly on my calculator. My calculator's not letting me go, not giving me powers. To the power of 1, close brackets, multiplied by brackets, 1 to the power of 2. And I get the answer of 24. So it's just nice that I can run it through my calculator. It helps you get used to using your calculator as well. So I know that that's correct. Absolutely. Yeah, and my units are good too. Right, next one. Okay, first step, reorganize the rate equation. Rate divided by Q to the power of 1 and H plus to the power of 1 gives me K. Input my data, rate my units are going to be back to the first one was there, wasn't it? So complete set of data, choose one. And the great thing is I get to ignore somebody. Let's just choose the second one. It's easy to use. Yeah, so rate is 64. So that's 64 divided by Q to the power of 1. So I'm going to ignore him. Q to the power of 1 at 0.04 multiplied by H plus, which is 0.4, gives me K. So 64 divided by brackets, 0.04 multiplied by 0.4. So I get a rate of 4,000. K, therefore, K equals 4,000. That seems like an awfully large number, but that's fine. What are my units? Right, my units become moles per dm cubed per second over moles per dm cubed over moles per dm cubed. Now, some of you are now, I'm bringing the reciprocal. Yeah, so moles to the minus 1, dm to the plus 3, s to the minus 1. I know for a fact that there are mathematicians now in this room who are going, oh, this is so easy. I can do all this stuff. Can I just say, by the way, I know it seems boring, me writing this equation out every time to get the units, but honestly, guys, I will make less errors than you do. So just bear that in mind. I'm just going to check that. 4,000 is a big number. Let's just run it through the rate equation. K is 4,000. I'm just going to run this rate equation here with K in place and using these two values here. Yeah, let's just run it through. 4,000 multiplied by Q at 0.04 multiplied by 0.4. Answer 64. There's my rate, so K is correct. Nice. Next. Okay, I'm running out of space here. Get rid of all this now that we've figured it out, and I'll move him out the way. There we go. Move him up there. Done. Okay, next. First, step 1, reorganize. Rate divided by t to the power of 1 gives me k. This is nice and easy. Gives me the most basic rate units as well. Yeah, so lob in my data, choose a set of data. I don't know, bottom one. Doesn't matter. Don't matter. So rate, I'm ignoring s, know that much. Yeah, s is 0. So rate is 300 divided by 0.2 to the power of 1 equals k. 300 divided by 0.2 gives me 1,500. My units become moles per dm cubed. Just going to do that over here. The rate units are moles per dm cubed per second. T is just moles per dm cubed, and it cancels with the top one. So the units are just s to the minus 1. Tick it if you got it. Next, rate equation again. Rate reorganize over w to the power of 2 gives you a k. Choose a string of data. Let's go for the top one. Right, input your numbers. Oh, the great thing is I can ignore x. They're just going to stick with w. So the rate is 0.016 over 0.02 squared. Got to watch out for that. 0.016 divided by 0.02 squared, and I get a rate constant of 40 units. Moles per dm cubed per second. Moles per, there's two of them, it's squared. Moles per dm cubed. Cancel, cancel, bring the reciprocal. Yeah, units are moles to the -1, dm to the +3, s to the -1. It's all maths. Not complicated, is it? Next, last one. Last one. Rate equals over m to the power of 2 equals k. Choose your data string. I don't know. Yeah, I don't know. Bottom one. Doesn't really matter. Insert matter lads. Rate is 2.4. Whoa. Wowza. Rate is, there we go. Rate is 2.4 divided by m, ignore a, 0.4 to the power of 2 gives me 2.4 divided by 0.4 squared gives me an answer of 50. Bottom one on the top, moles per dm cubed per second over moles per dm cubed, which cancels over moles per dm cubed because it was to the power of 2. Give it the reciprocal. Mole to the -1, dm to the +3, s to the -1, and I'm finished. Right, guys, it's the end of the homework. Let's tally it up, shall we? So we said that there are 1, 2, 3, 4, 5, 6 questions in total. So 6 questions. Each question has 1 for the orders being correct, 1 for the rate equation, tick, 1 for the value of k, and 1 for its units. So 6 times by 4 gives me 24. Your homework was out of 24. I will share it with you, folks. I will share the document with you. This one was out of 24. This is where it might be really handy. I think I am actually, wow, amazingly, the lesson's not far off being done anyway. I've got to come back to my, and then I'm going to take my my names from the mark book. I'm not just going to put them in randomly. 12E, here you go, copy. I'm going to put that one over to here, delete the people who need to be deleted. Sherlin's now gone. There we go. Sherlin's gone. I think that's it. Kinetics 1 out of 24. Get rid of that. Get rid of that. There we go. Share. I want make can edit. Share advanced. Let's do advanced. Can change. I want them to be able to edit. Can view. Can edit. Save. Right, there's the link. See. And then I'll post that on the classroom. That sounds like a good plan, doesn't it? Right, I'll stop sharing. Go back to hang on, I've lost it. Wait, back. You could use a different set of data, or you could just use a different set of data. Okay. Right, guys, I'm going to end the lesson there, having gone through that, and I'm now going to post onto the classroom. Post onto the classroom. Let's go year 12. Nope, let's do 12E. Nope, can't find you guys at all. Oh, I've not got a class at all, Chem. Oh, I do. Year 12 Chem. There you guys are. Right, there you go. Guys, I've shared it on Google Hangouts. Go and just, there you go, Tenzi's up already. That's amazing. So I'll then go back to my sheet and see whether or not you guys are starting to fill in your data. That would be amazing to see data go in there, guys. Oh, look at that. You guys are appearing. That's amazing. Yay, it's great. So out of 24, I'm even going to make them go into the middle. Oh, Ivan smashed it out of the park. Well done. There we go. Well done, Ivan. Great job. Once you have inputted your data, you can get going, and I will post onto the classroom Kinetics 2, folks. Yeah, and I will end my webinar there. It has been an absolute pleasure. You guys have done great. Thank you so much all for being so great and filling in the data and getting on with the homework. Thank you. Look at that, full marks on the homeworks. That's amazing. I'd love to know, Ria and Nikita, where you lost your 1 mark. Which one foxed you? Great job, guys. Really proud of you. Well done. Oh, I needs to go. Delete row. There we go. Just Dat and Mika now, just to fill out their data. Oh, you guys are so welcome. It is always, I love teaching you guys. You guys are great. Thank you so much. I'm sorry I've not been my usual self. Just not quite feeling right this afternoon. And I will see you guys next lesson. I will put the kinetics homework. You know what? I'll do that now if I can. If I can track down, go to my classes, see if I can post onto your classroom Kinetics 2. I do need you to be aware, these questions, folks, there is an issue here. I messed up on the units. Yeah, it's fair enough. There is an issue. The issue is these aren't hard enough. They're not. When you start looking at the real ones and you start seeing the crazy numbers they use, it's just a bit of a pain. Just going to have a look at Kinetics 2, see whether or not the numbers are slightly, yeah, the numbers are slightly harder. Yes, much more realistic. I like it. Okay, cool. I think they're good. They are better. I love it a lot. Cool. I will post Kinetics 2 up onto the classroom right now. I always think it's worthwhile me doing that, isn't it, whilst I'm on the chat, because it just means that I get it done. Classwork. So I have you guys. I'm high on chemistry. Ben, it's the only way you can get high is on chemistry. We've got kinetics homework 2. Do these for Wednesday. For Wednesday, guys. For Wednesday. I'll add the file. I'm glad that you found that funny, Ivan. I'm sure there'll be people going, I don't get it. There we go. Upload Kinetics 2. Boom. We're in. I'll put a due date of Wednesday. There we go. And go assign. You guys know what you're doing. Guys, I promise these homeworks are really worthwhile doing. You know, they really will make you better chemists doing them. No, you know, on Wednesday, I'm going to set you a homework for Thursday. And I know that, you know, I'm not giving you an awful lot of time there. If you can't complete it in time, don't worry. Just watch the webinar back, you know, watch it anyway. And you can do it with me if you like. You know, at the end of the day, you guys doing your homeworks is very much kind of like, well, it's up to you. If you guys want to if you guys want your A and your A star for chemistry, then the homeworks will definitely help you get there. Guys, I will leave you be. Have a great rest of your Monday. I'll see you all soon. See you on Wednesday.